Forecasting using exponential smoothing. Exponential smoothing is a type of weighted moving average, and it is a popular statistical tool to produce a smooth time series for presentation or to make forecasts. In this video, we are going to show you how to forecast data using these different types of smoothing methods.
Firstly, we will look at how to forecast using simple exponential smoothing. We will use this example. Since we do not have any information about 2013 data, we will simply use the first forecast as the first actual data. And here we will apply the formula. Alpha, we need to fix alpha every time we use it, times the previous data plus 1 minus alpha, again we fix it, times the previous forecast. Here is our first forecast. We just click and drag until the last month we will have the forecast. Here we need to input the value of alpha, let's say 0.3. Here you will see that the value changes. Let's say we put 0.5. Again you will see it has different values. Now to find an optimal alpha for which the error between the actual data and the forecast is minimized, we will do the following calculations. The first absolute error, we do not need to calculate it since it will be approximately 0. We will do the second one. For that we will use the absolute function in Excel equal to absolute of the forecast minus the actual data. Again we just click and drag. The mean squared error is simply the absolute error to the squared is equal to absolute error to the squared. Again, now the MSE, the mean squared error, is the average or the mean of all the squared errors. Now that we have found the MSE, we will use the solver to find an optimal value for alpha. The solver, we will set objective as the mean squared error to minimum, and by changing variables, the variable will be the alpha. We need to add two constraints because alpha is between 0 and 1. We just add the constraint and then click on solve. As you can see, the Excel sheet has found an optimal alpha which is 0.286 approximately.
Well, this is the forecasting using double exponential smoothing, where the forecasting is given by this formula and the trend is given by the second formula, where alpha is a data smoothing factor which lies between 0 and 1, and beta is a trend smoothing factor again lying between 0 and 1. To forecast beyond the given period, we apply the third equation, that is the addition of the two formulas. Consider the following example of production of coke. We have the production per tons per week. By applying the above formula, we can calculate the forecast and the trend and the including trend. Let's calculate the forecast, trend and forecasting including trend in Excel. So we have here the following set of data: the initialization, which is a difference of production over number of weeks. Here it is the average. Then here we calculate it by just simply applying the following equation. Just add it with alpha. Here it is given multiplied by actual minus forecasting including trend. Should not forget to fix the value of alpha. Obtain this, and this is given by the initialization here just beta. Again, we fix the value of beta to multiply by forecasted difference of forecast minus forecasted including trend. We obtain the following, and then here we just add both forecasting and trend. By dragging the following, we obtain the forecasting value, the trend. Here you get the forecasting including trend. To calculate the optimal alpha, we use a solver in Excel, which was previously explained. Thank you.
Our third example is triple exponential smoothing using the multiplicative method. Here's an example of partition for which we have to find the sales in year 5. Our three parameters, alpha, beta, and gamma, have been given random values between 0 and 1. We have already initialized values for our level, trend, and seasonal data. Level, which is the average in the sales in year 1. Trend, which is the difference between the sales in the first quarter of year 2 and year 1 divided by the period, which is 4. Seasonal is the actual sales divided by our level. Now we have to find the level, trend, and seasonal data at time 5. This will be equal to alpha multiplied by the actual sales at time 5 divided by the seasonal data at time 1 plus 1 minus alpha multiplied by level at time 4 plus trend at time 4. Here we have to fix our parameters. Trend will be beta multiplied by level at time 5 minus the level at time 4 plus 1 minus beta multiplied 1 minus beta multiplied by the previous trend. Here again, fix the parameters. Seasonal is going to be gamma multiplied by actual sales at time 5 divided by level at time 5 plus 1 minus gamma multiplied by the seasonal data at time 1. We take this and then we drag. Now having these data, we can forecast our sales. Forecast is level at time 4 plus trend at time 4 multiplied by the seasonal data at time 1. This is for time 5. We then drag this until no more observation is available for level and trend. Since at time 18, 19, and 20 there is no observation for level and trend that we can use to find the forecasted sales, we will use the same level and trend that we have used to forecast the sales at time 17. And here we have to multiply our trend by the quarterly value. So this will give us level plus trend multiplied by the quarterly value multiplied by its seasonal data. Here we fix level and we fix trend, and then we drag this. So this is our forecasted
Our last
sales.
example is additive model in triple exponential smoothing. Here we have the formula that we will use in our example. So let's start. This is an example where we have to focus bike sales in year 5. First, we will initialize our level, trend, and seasonal data. The level is the average of the sales in year 1. The trend is a difference between sales
in the first quarter of year 2 and year 1 divided by the period. The seasonal data is that of the actual series divided by the level. We will now use the formulae to forecast our data. Level will be alpha multiplied by actual series in time 5 minus seasonal data in time 1 plus 1 minus alpha multiplied by the previous level plus the previous trend. Our trend will be beta multiplied by level in time 5 minus level in time 4 plus 1 minus beta multiplied by previous trend. Our seasonal data will be gamma multiplied by actual series minus current level plus 1 minus gamma multiplied by seasonal data in time 1. Then we drag the data up to time 16. The focus will be our previous level plus our previous trend plus seasonal data in time 1. Then we drag the data up to time 17. To find our focus for time 18, 19 and 20, we will use the level and trend value that we have used to find our forecast for time 17. We will have to fix it and drag it. Since we do not have any subsequent level or trend for time 18, 19 and 20, we have to multiply our quarterly value to the trend data. To find our forecast for time 18, 19 and 20, we will use the level and trend value that we have used to find our forecast for time 17. We will have to fix it and drag it. Since we do not have any subsequent level or trend for time 18, 19 and 20, we have to multiply the respective quarterly values to the trend data. This is the end of our video presentation.